So welcome everybody. We're going to do more or less the same as we've done previously. Have a section about the new systems and where we're at. A little bit some of the details of the migration, and then some stuff about the training. And then going to end up with one or two little things about the actual new systems technologies, the software and the scheduling issues that users might actually see a change in. I was kind of hoping that today I would be able to say I've logged on to the new systems, and so have our analysts, but no luck quite yet. Although the systems are up, they're running, but still at the install stages, and we're really kind of hoping that next week we will get on them. So yeah, the next slide there. Here's the update. So as usual, our Arbutus, the cloud, that's up and running, done. And right at the moment, they're upgrading the network to connections through area and regional ORANs. So that end of things is happening across the board, and that'll be great. These very high-speed networks between. Here, it's installed, it's currently running the high-performance LINPACK benchmarks, and CEDAR, if you remember, just is the GP2 machine at Simon Fraser at SFU. It's doing well. I understand the LINPACK benchmarks from NVIDIA for the GPU nodes have run, and they're getting something like 1.5 petaflops out of the system. So that's not fantastic, but it's only the GPUs, not the rest of the machine. So that's nice. It certainly puts us well into the top 100, I think. So we're expecting what I called alpha access next week, early June, and that's for the analysts. I'll have a little bit more to say that next. And then sometime later on in June, mid-June, later on in June, we'll open it up for everybody else. That's the opportunistic. And again, I'll say a bit more about that. Graham is pretty much exactly the same. That's the Waterloo system. They've been running their benchmarks. They had formal acceptance. They've met all the acceptance requirements from the vendor, from Huawei. So we're also expecting sort of any day now to get on CEDAR and Graham. So yeah, a bit delayed. There have been a lot of all the usual little hiccups, things like bent cabling, little issues, some of the nodes. Node replacements, that kind of thing, but we're almost there. So I was really hoping to be able to say I've actually run a job, but I can't do that quite yet. Niagara, that's the great big large parallel machine, estimated at 60 or 70,000 cores in Toronto. That's the RFP process is continuing on. Just to remind you that the RFP process was delayed for that machine by the recommendation of the expert review panel, who said that new Intel CPUs and chips were coming out and that we didn't need it right away. So that one we're only still in the RFP stage. But the shortlist, there are 5 shortlisted vendors. And the process is a last and best offer phase. So the vendors are being interviewed right now, and they'll come back in the next few weeks with their last and best offer, and then decision gets made. So I think late 2017 has been the aim. I suspect it'll be into 2018 before that system really comes up for users. But it'll be great. That's another, say, 60 or 70,000 cores, and we're desperate for cores. We've got so many applications through the resource application competition for essentially straight cores, straight flops, and it'll be great to get Niagara up and running and to take over some of that stuff. Okay, next slide, I think. Oh yeah, full production with rack. Yeah, maybe late June, when we actually late June, maybe early July, when we implement the rack 2017s, the resource allocation priorities, and go to production. So pretty compressed schedule. Next slide there, Aaron. So this alpha access next week, we've invited a few specific users, identified users who, they're some of our biggest users who can really handle, really hammer the machine and see what we get. The rest of us, that's the analysts, will get on as quick as possible, and so it's staff familiarization. Essentially, everything is ready to go, whether it's the documents, the schedulers, the user accounting stuff, but we haven't had the real big machine to try it on. So the effort in the next few weeks will be to get staff onto it and to find all those bugs, fix them up, finalize the docs, get everything going. We're hoping to do that, give or take a couple of weeks. At that point, next slide, we go to what we're terming opportunistic use, and essentially we're going to open up the machine to anybody who wants, the machines, both Graham and Cedar, to anybody who wants to use it. This is pretty compressed. I think if we're a sort of commercial, working with stock markets operation, we would spend months doing our own testing, careful analysis of performance, etc. But we're not. We're researchers, and we know that that our researchers, our users, just want to get on the machine. And so yeah, we're going to open it up as early as we can. As soon as we figure the thing is vaguely stable and has the right applications, off we go. That'll be flat priority. No resource allocations. Just everybody gets in and has the same priority on the system. The system will be, I'm sure, still unstable, and if anything needs to be updated, fixed, we'll just take it down and update it. So this is definitely a beta test end of things. We won't be guaranteeing any kind of uptime, but off you go. It'll give the users a chance to familiarize, update your scripts, migrate some data, recompile, test performance, all those kinds of things. And also, you can familiarize yourselves with the file systems. There's not much there. I think you're all pretty much used to having a scratch system for the high-performance stuff, and some more persistent home space where you've got much more space available and can keep things more permanently. I've got three things in boldface there. Scale-out testing. Yeah, the previous phase, the alpha testing, where we have a few really big users who just use the whole machine. But in this opportunistic phase, well, we're hoping that lots and lots of users get on it and they just play with the machine doing all sorts of different things. And of course, that's the diverse usage as well. They'll be running all their favorite codes, their favorite applications, and pulling out all the issues and the problems. Also, I just note that, yeah, our documentation, we've rewritten or written almost all of it. That's the Research Support National Team. And there are certainly going to be some places where they're misleading or not perfect. So we'll expect users to be identifying those kinds of issues. So at last point, yeah, it's really important to report all issues when you see them to support@computecanada.ca. So if you come across sort of any issues, yeah, send them to us, and we'll try to respond and support. The RSNT support group is gearing up to have a number of support analysts available and ready to go, because clearly there's going to be a big uptick in tickets in the first couple of weeks or first month or two. So we'll do our best. Of course, bear with us. If we get overwhelmed, it'll take a little while. There will be a known issues page where if we know something's gone wrong, we'll update that page, and hopefully users can have a look at that and see what's going on. There's also a status page. I put the URL there, status.computecanada.ca, and that's probably a good thing. Right now it's almost blank because nothing's happening, but it will ingest all the logs and do the uptime and tell you that the machines are up and all that kind of thing. So you might keep an eye on that in the next few days to see when we're up. Yeah, so this is going to be an exciting time, and then when we're happy with the results, we will go to production and implement the resource allocation priorities on the new systems. Yeah, and then we're good. Okay, national storage, not much to say here. The silo interim storage is still up, running, and working. Remember, due to the time constraints at USask, we moved all the old University of Saskatchewan silo users off to some temporary storage available in Graham and at SFU and Waterloo. So that's still going strong. It's still there. No changes. We have started our remigration project now that we know where the machines are, but I think it'll be at least a few months yet, a couple of months before we get back to everybody and move away from the silo interim onto the permanent project space. So we'll get back to you on that one. Keep using silo. If you're an intra-silo user, just keep using it as normal. And then the National Data Cyber Infrastructure, the NDC, that's the project space, 10 petabytes at SFU and 13 petabytes at Waterloo. The Waterloo one is actually available right now through the DTN node, so you can look at the docs wiki if you want to get into it. But fundamentally, these are attached to the clusters, and you'll access them when you get a chance to SSH into the head nodes. So they're pretty much ready to go. And as soon as the clusters come up, they'll be attached as well. Yeah, so we'll have, essentially, this is a complete system coming up next week for our alpha test, and then a couple of weeks later. The object storage, that's sort of 5 petabytes at most sites, and that's the system that will geo-replicate. It's really good for big data sets, for experimental data, those kinds of things. There's quite a lot of demand for that kind of approach. I think I've mentioned it before. We're certainly seeing a lot of these big experimental data sets or observational data sets, and the right place for them is an object store. And then you can say replicate, very reliable storage, and available at many places. The storage national team has been working mostly on the file store, the 2 new systems, so they haven't had a lot of spare cycles to work on the object store. But it's coming. We're aiming for later on in the summer, and certainly test and examples are up and running, and we're working with DDN, that's the Data Direct Networks, who are the vendor for the object storage service. It's called WAS. Yeah, so that'll come, and I think we'll be reaching out to users really pretty seriously, because we'd really like to get some of these big experimental guys onto something like an object store. And remember, that's based around having a web front end, some kind of portal platform, and it would disseminate the data out to users, maybe from around the world, international users, and the object store is just the perfect place for that. So you'll hear quite a bit more from us about the object store, and of course Scratch, the Scratch file system. Yeah, it's attached to the clusters, and it was bought with the clusters, and it's available already, or at least it's up and running on the systems right now, just because you have to have a Scratch system. Right, next slide then. Yeah, it's worthwhile then touching base too on the legacy systems. The key one is Hermes and Nestor in Victoria, which in fact were defunded yesterday. So I've got one more slide about that. I think you guys who are on Hermes and Nestor have received a communication about the issues that we've got with that. So I'll get to that in a second. Breezy and Lattice, that's at the University of Calgary, are scheduled for defunding on August 31st. But there are 3 systems at Calgary: Breezy, Lattice, and Parallel. Parallel will keep going until the end of March, where most of the rest of the systems will be defunded. So the file systems will still be there, the shared storage will all be there, but Breezy and Lattice themselves will, as with all these systems, shift to being the responsibility of the institutions involved. And so, yeah, you can go to that web page, the www.westgrid.ca/migration process, for more details. It may be that that the institutions will keep these systems going a bit longer. And Edmonton, Hunkaby, and Jasper, October 1st. So those are the immediate ones. Pretty much everything else will get defunded at the end of March next year, and hopefully we'll have the big new large parallel system. And there are other grants. Phase 2 of the CFI grants should be coming in. We know a lot about them, but we can't talk about them too much yet. No official announcement. So I think we're kind of, this is the transition year. We've said it many times. We're trying to shoehorn people in and out, and we'll keep doing that, keep working with users, and we'll look forward, I hope, to next April, when we have the new systems, defund the old systems, and we're back on a more standard, even track. Yeah, next slide. Yeah, I'll get back to Nestor and Hermes at UVic. So Hermes and Nestor were defunded. So generally, you can't submit jobs any longer on Nestor and Hermes. However, UVic really nicely are keeping the data system going and the head nodes. So we didn't have a sudden urgency of finding something like the silo interim storage for the storage at UVic. So the storage is still there, and if you and right now, as soon as we get the new machines up, we'll give people access to the new machines, and you can have a go. If you do need compute between now and then, yeah, send us a message, support@westgrid.ca. Essentially, all we can do is try to fit you into some of the existing machines. So that's our, these are expensive machines to keep going, and of course the institutions have a lot of matching funds. So fundamentally, we really want to get these out of the way as quick as we can, because they're an expense. And of course, all the new grant money is going to the new systems. The point there, the second point in blue, that UVic users, well, in fact, UVic will be keeping Nestor and Hermes going for their own purposes, their own internal institutional researchers, for at least a little while. I would guess a couple of months. So UVic users, can still submit jobs. Yeah, okay, so Nestor and Hermes are really our kind of the one place where, due to some of these delays and the problems in getting everything done, we're going to be out in limb a little bit. Sorry about that, but give us a call and we'll do our best to get you into some place. Yeah, next slide. Aaron, thanks. Here are the contact emails if you want to go to ask more about the UVic systems and how long they're going to keep it going. Send to sysadmin@uvic.ca. UFC has support at hpc.ucalgary.ca, and for U of A, the research support at ualberta.ca. And that's so UFC, that's Lattice and Hermes. No, Lattice. What's the other one? Anyhow, the two-month, and U of A is Jasper and Hunkaby. Okay, yeah, next slide then. I should note that these slides will be available to everybody. I think they're going out on the web page. Yeah, then system outages. I think we've had a little bit of a rough couple of weeks, a few weeks lately. So I thought I'd put a quick slide up here just to note that, yeah, these old systems really are old. What we've done, I just want to emphasize it, is that storage almost is kept under vendor support. We really felt we had to keep the storage going and we had to keep that reliable. But the nodes themselves, the compute nodes, they are not under vendor support. It's very, very expensive. The spare parts are really not available anymore, and vendors are shutting down their support groups for these old systems. So we've done our best to keep what we think is critical under support, but the compute stuff, we're not. So Orson had a short power failure back last week. Some nodes were crashed and jobs lost. Now, that's not an old machine. That was just a standard power failure, and that occasionally happens, but Orson came up nicely. Hungabee had a hardware failure. Hungabee is the big SGI shared memory machine at U of A. It's a hard machine to keep going, and the issues are around the fact that due to the shared memory, there's quite a complex architecture involved, where the individual nodes have to look like they're one connected large shared memory pool. The slide was written a few days ago. In fact, Hungabee is back up now, and through some very clever work with Camille at U of A, the Hungabee, which has just taken out of service one of the chassis. So kind of there's a 7/8 of Hungabee available. Some really clever work to handle the fact that architecture really couples everything together, and it's very hard to take out small bits of it and still have the machine run. So I think we'll emphasize that Hungabee is really old. It does have these failures, and we can't guarantee much about it. It's supposed to last until the end of September when it gets defunded. But it could go down seriously any time. The alternatives, if certainly both Cedar and Graham have some big fat nodes, so getting on to Cedar and Graham is the first thing to do as soon as possible. If you do need some really fat nodes, then the Centre for Advanced Computing in Ontario, CAC, also has some resources to offer. So again, give us a call if there are any issues, and we will do our best to keep Hungabee going, or at least U of A and the U of A systems team will do their best to keep Hungabee going. Bugaboo is the machine at SFU, and the issue there really is that there's also Cedar at SFU. So every time they want to bring in, do something in the data center with Cedar, just because they're installing the new gear and all the rest, that also means that Bugaboo can be affected. And in particular, last week they had a power upgrade with a new diesel generator, and that's to give the backup diesel power for the new machine. Well, Bugaboo had to go down. So there were announcements. I think you saw those, and the whole thing was brought down while the power was upgraded. However, Bugaboo didn't come up very well. There's an old controller for the file system, and again, just that whole thing is getting old, and it took a little while to actually get that repaired and fixed a few days later. So instead of coming up right away, Bugaboo took a few days to come up. I have to say, some really intense work by again the Bugaboo sysadmin team, the SFU team, who had to sit there and do all the usual things that they do with those old file systems. Still under support, so we will keep those systems going. But yeah, they do crash. And then Grex, that's the Manitoba machine. On May 19th, they replaced the storage system. Now, that was one of those ones where when one looked at the details of the costs involved with either buying a support contract for the old storage system or just buying a new storage building block, well, the storage building block was cheaper and higher capacity. And of course came with a warranty, so the support was built in. So with Grex, we decided to just buy a new storage system for it and keep it going. The issue there was that we're now using what's called the auto-mount system. So when you log in, auto-mount notices that you logged in and mounts your home directory. It's not quite as straightforward as that, in that you really have to actually look at the home directories, ls can suddenly give no results, and that looks that's a panic situation when you suddenly realize there's nothing. Well, it doesn't look like there's anything there. We sent out a message about that. I think everybody got it, but and we haven't had any complaints since then. So sorry about that. I think, but at least the storage itself now is much faster, larger, and hopefully far more reliable, so we can expect Grex to keep going now quite well until next year. Yeah, so there's a quick synopsis of our system outages. I expect to see a few more over the summer, and we're certainly doing our best to not to do anything drastic. Certainly we don't want to put a big effort into these old systems if we can help it. But they are old, and they are slowly going. I should note that if a node goes, and we are having nodes going, they're slowly decreasing in size for everything except Hungabee, for the straight clusters. That doesn't matter too much. The node crashes, and whichever jobs were running on the node die, and we take the node out of service, and the machine ends up being a tinge smaller than it was. But most users don't see those. So there's also that kind of continuing wastage going on. Yeah, so it's really time to get the new systems. Okay, back to some more interesting things. The training on the new systems. The Research Support National Team has done a ton of stuff, and I've got some notes later on about the software stack. For instance, the training micro team working on introductory videos for Cedar and Graham. In fact, Alex, who will talk shortly about the WestGrid summer schools, has been working with the training guys on developing these videos. But of course, our issue is just that we've got all these final steps to take when we actually get on the machines. So the actual current version of the documentation is there. It's not tested on the real thing yet, so I hope it's pretty much there. But in the next few weeks, it'll be updated. There are sections about getting started, storage, software usage, running jobs, programming, visualization, already up there, and essentially ready to go as soon as we figure out, as soon as we get to test the details and the machines come up. So it's all happening. It's all happening sort of in parallel as we work away at this. Yeah, next slide. Yeah, so just for a second, I don't see any questions coming in, but anything, any clarifications anybody wants? Yeah, looks good. Okay, let's continue on. And I think at this point, we'll hand off to Alex, who is, say, our visualization coordinator and becoming our sort of training coordinator for the WestGrid summer schools. Over to you, Alex.
All right, thank you, Patrick. So this year we are planning 2 WestGrid summer schools, one at UBC in Vancouver in June 19th to June 22nd, and the second one at the University of Saskatchewan, July 24th to 27th. The registration is now open, and you can register and view the detailed programs of the schools by visiting the websites listed in these 2 slides, or by checking the events section at our website, westgrid.ca. At each summer school, we'll have a variety of courses from introductory and intermediate level classes on parallel programming and other scientific computing topics to short courses from domain specialists who will introduce to the audience the best tools and practices in their respective disciplines. So nowadays, there are many HPC users who don't write parallel codes themselves. Instead, they run popular community codes, so for example, quantum chemistry codes or molecular dynamics codes. And for this reason, we decided not to teach the traditional introductory MPI message passing interface and OpenMP programming classes. At UBC, we'll have a more advanced course on hybrid MPI plus OpenMP programming, and we'll have a full-day GPU programming course with CUDA and OpenACC. Plus, we have courses on parallel computing with Python, Julia, MATLAB, parallel data processing with Hadoop and Spark, scientific visualization, web APIs, and a few others. The bioinformatics session at UBC will be taught by 3 instructors from the Genomic Science Center in Vancouver. So we're still not sure if the new systems, compute candidate systems, Cedar and Graham, become available by the time of the summer school, the first summer school in Vancouver. If they do, then we will teach an introductory hands-on course on these systems as well, covering the job schedule, the software environment, best practices, debugging, and profiling and code optimization. And at UBC, we'll have 2 parallel streams with lots of choices, so it should be a very interesting summer school. Next slide, please. In Saskatchewan, we're doing something very similar, reflecting the local research interests in bioinformatics and material science, and local expertise in PATSI and research data management. The first 2 days in Saskatchewan are going to be plenary sessions for everybody. And then the last 2 days, attendees will select between courses in 2 parallel streams. In Saskatchewan, we also decided to try something very new this year, teaching a full-day class on parallel programming in Chapel. Chapel is a new programming language that works both on shared memory and distributed memory machines, effectively replacing both MPI and OpenMP. Chapel is very Pythonic in its approach, and it is much higher level than MPI, so it is much easier to use. What you normally achieve with maybe 40 or 50 lines of MPI programming, you can do with just a few lines of Chapel, so I'm sure everybody's just going to like it. And the performance is essentially the same as any other compiled language code in C++ or Fortran. Chapel allows task parallelism. There are many ways to launch new processes, and data parallelism as well. You can define what they call domain maps and structures on top of these domain maps that are distributed among many nodes. Chapel is really nice tool, a very intuitive, open source, and we're really excited to teach it in Saskatchewan. I should mention that the summer school sessions will not be recorded or broadcast this year, as they're meant to be in-person training events with many hands-on exercises and lots of interaction. But we'll try to make the slides for individual courses available online shortly after the summer schools. Next slide, please. Okay, so back to Patrick. All right, there was a slide there that was removed.
I think it's the next one. Try the next one, Alex.
Okay, next one. Okay, well, it's back to Patrick. So I just want to mention that there is also another event in Vancouver, the Genomic Analysis Workshop, that's going to run for 9 days, starting in a few days. And my understanding is that it's very popular there. So there's quite a lot of people who already registered for it, and it's going to be both in person and broadcast to other sites as well. So that's all from me.
Thanks, Alex. Any questions from Alex there? Yeah, just the WestGrid is a very distributed organization across multiple provinces. So trying these summer schools, well, we have to have more than one. It would be nice if we could just have one and get everybody to come there. And places like Ontario and Quebec have that approach. But we're going to be putting on, say, 2 of them this year, and maybe another couple next year, but at different sites. So many thanks to Alex for getting these organized. I'm really pretty excited to hear about Chapel. I think that sounds really good. It seems to me in my reading, there have been some really interesting developments around parallel programming. MPI is it 20 years old now or 30 years old?
20, 23, 25 years old, something like that.
Yeah. So it's tough to program in MPI. There's no doubt. It's very powerful, but with the development of clouds and HPC in the clouds, machine learning kinds of stuff, getting away from that rather complex MPI approach and starting to work into something like Chapel, where the whole language is built around parallelization. It's become really pretty exciting. And yeah, I'd really recommend that one. Yeah, good. Okay, so thanks, Alex. Yeah, and I've got just a few, maybe slightly more specific slides now about the new systems, just to highlight 1 or 2 differences. So the first thing I wanted to talk about was just the system software. So quite an effort has been made to ensure that the software on Cedar and Graham is identical, the software stacks. So it's in fact being compiled in a central location and then put onto CVMFS, the CERN file system. That's the high energy physics guys who have done this for years. And then all the nodes and all the on both Cedar and Graham just mount that software stack. And there's some really clever stuff about making sure all the right libraries, all the right prerequisites, and everything else are built into the CVMFS approach. So really quite pretty, and I think that makes it very valuable for users. You'll see essentially exactly the same things happening on Cedar and Graham. One thing I will note is that works great for open source software where it doesn't cost us anything to build it and disseminate it. For commercial software has all sorts of different licenses, and it's not quite, in fact, nothing like as easy. In practice, because of the costs involved, impossible to make it identical, to make all the software available on both Cedar and Graham. I have access to some of the lists that the teams are working on, but they're not publicly available yet. Still working with vendors about the costing the licenses, how we do the licenses, all that kind of thing. I think, well, it is clear that users will see more or less the WestGrid model. And if you remember, the WestGrid model is that there are a couple of very well-used, broad commercial packages. Gaussian comes to mind all the time, where we actually buy a license and put it on one of the machines. But for all the rest of the packages where there are 1 or 2 or 3 users, in that case, users supply their own licenses, and we set up our machines so that they can use the user-provided licenses. And I think the same approach will be with Cedar and Graham. We haven't got anything really well defined there, except got the lists and working with vendors. So it'll be a little while yet before that comes out. Again, keep an eye on the docs wiki, and stuff will appear there. I think everybody's familiar with modules and the module command. So the software stack will be the same. You'll use the module command to load the configuration for whatever your software packages are. So that's great, and the page is there on the docs wiki. There's the link, and you can go and have a look at that. I think everybody's familiar with it. As I'm sure you all know, the issue really is what's the configuration of LMOD, the modules package, and you just have to get used to what the hierarchy is, where your favorite software package is, that kind of thing. So yeah, you'll have to have a look at that, and the place to have a look at that is on the software list. So there is a software list up there. It's auto-generated by the whole build process. It's really kind of nice, but users see that list. I think we've mentioned it before. Yeah, go and have a look. It gets updated as new builds are available. And if there's anything particularly missing, write to support at Compute Canada. The Compute Canada guys are doing this all centrally. So well worthwhile. Yeah, and then one other topic I wanted to mention is scheduling. And this is a change that users will see. So the key thing is that we're not using the Moab and Torque scheduler combination that users are familiar with on WestGrid systems. Instead, after quite a lot of sort of RFP work looking at the various vendors, we went with the open source Slurm workload manager. Yeah, Slurm is open source and free, which is really good. It's kind of matured out now, and it's pretty powerful, so it does everything. The downside is that yeah, our users haven't seen Slurm. Certainly not in WestGrid. Slurm has been used, I think, a couple of times in Ontario. But so this is new. Now, I just also wanted to note that Camille at U of A is the team lead for the scheduling micro team, and WestGrid actually has quite a lot of pretty serious scheduling expertise. I should just note, schedulers, they're almost an art. How do you decide when to run jobs, what the priorities are, whether they're large jobs, small jobs, long or short jobs, single node versus multi-node MPI kinds of things. Now we've got a large number of GPUs. We've also got a mix of nodes with small memory and then large memory fat nodes. So juggling the scheduler is something that I think everybody knows we play with quite a lot. We fine-tune it depending on the actual usage. So it's a very complex operation to get a scheduler up and running, and I think we all expect that the initial scheduler configuration will not be perfect. In fact, it will be considerably less than perfect, and the scheduling micro team guys will be looking at performance, looking at the jobs that are running, and tweaking it a bit to make sure we have efficient usage of the system and also as fair usage as possible. So I've got, I think the next slide, I just had an example. Any scheduler from the user point of view has a basic approach. You define the resources, define the workflows in your job script, submit the jobs, and you can monitor the jobs that you've submitted. And somewhere in the middle there, after you submit the job, the scheduler looks at what resources you've requested and tries to fit your job into the system and starts it up. Some links again. The basics they're all in the docs wiki. You can just go and have a quick look at these. The policies. There's some advanced stuff at the Slurm website itself. Camille has had some excellent presentations that he's updating for the new system, so we'll be doing some of that kind of thing as well. And you can watch for announcements then on the WestGrid web pages. I just put two quick examples there. You can see that the job scripts are not quite the same. They have that S-batch key, and then the details, how you decide the number of tasks, the memory, the time you want, whether you want GPUs, all that kind of thing can be created there. Otherwise, of course, it's a script which runs your applications or workloads. So there'll be some changes there. You will have to change your batch scripts, and hopefully this opportunistic use period for a few weeks will give everybody a chance to submit hello worlds and maybe a few parallel benchmarks and such to get the hang of using Slurm. I think you'll find that Slurm does everything that Moab and Torque do on the existing systems. But there will be, I say, differences, so you have to get used to. So no lack of functionality, but syntax and detail differences. Just to note, we are not changing the scheduler on the legacy systems. We're doing no extra work on the legacy systems if we can help it. So they will still use the standard Moab and Torque scheduling operation. Anyhow, so that was kind of fun. There we are. Support. End of of our presentation today. Support at westgrid.ca, the website for announcements and such. And then we keep referring back to the docs.computecanada.ca wiki. And let me emphasize, I think it's a great idea to go and have a look at that, and especially as you get on the systems, and tell us where it's misleading, where things are, where we've forgotten to add stuff. Where we've got it wrong. I'm sure there are going to be some actual inaccuracies on the docs wiki, and we'll update those as quickly as possible. Yeah, I think that's about it. Any questions? Nope, looks good. Yeah, okay. So we're looking forward to the next couple of weeks.